again, the ventral aspect and the dorsal aspect. It's a very tiny area. It's only about that big. It's tiny. If you look at it in a cross-section like this, here's our big fat pons. There's the mammillary body right there. So if I go back, there's the mammillary body. So it's only this little area here. That little area there, ventrally. And dorsally, you've got the inferior superior colliculi, and in the cerebral aqueduct in the middle of it. Very, very thin area, very short area. There are two nuclear groups that you'll find there, cranial nerve nuclear groups. This is the first one here. This is the trochlear nucleus. I know it's the trochlear nucleus for two reasons. One, again, it's the only one that comes out the dorsal aspect of the brainstem. And two, it's the only one that crosses internally. So the right trochlear nucleus controls the left superior oblique muscle. You got to keep that in mind if you have a problem with the superior oblique. The superior oblique is useful in looking down and in. So people have a problem reading and they have a problem walking downstairs because this one side doesn't move the eyeball down and in appropriately, and you see double vision. You got to understand, if you're doing the extraocular eye movement muscles, and you see that if this superior oblique that's not working, it's coming from that side of the brainstem, because it crossed. The third nerve is right here, right above it. The third nerve has two nuclear groups. One is somatic efferent. So like the fourth nerve, it's going to go to extraocular eye movement muscles, which it does. All others three, plus the levator palpebrae superioris, to open your eye. 7 closes it, 3 opens it, right? It's ipsilateral nerve, doesn't cross like 4. There's the MLF right beside it, which coordinates it with the vestibular nucleus. Also in the mesencephalon, there's this big nucleus right here called the red nucleus. Remember that from yesterday? The rubrospinal pathway facilitates flexion. If you lesion above this level, the red nucleus is free to do what it wants to do, and you wind up with posturing, flexion posturing. Between the red nucleus and the cerebral peduncle, remember there's our cerebral peduncle, right there. So between the red nucleus and the cerebral peduncle is this nucleus right here called the substantia nigra. That's where you'll find the substantia nigra, in the mesencephalon. The other component of 3 is the parasympathetic component of 3. That's in my favorite nucleus, and one of these days I'm going to get a t-shirt that says this. It's called the Edinger-Westphal nucleus. Edinger-Westphal, I don't know why. I mean, it's just Edinger-Westphal, like Lesch-Nyhan. It's kind of cool. I mean, the name, not the disease. Edinger-Westphal nucleus provides a parasympathetic supply to the ipsilateral ciliary ganglion, and from the ciliary ganglion to the eyeball. Parasympathetics, what do they do to the iris? Dilated or constricted? Constricted. All right. So if I shine a light in this eye, that retinal information comes down into the mesencephalon and synapses on the Eddinger-Westphal nucleus. It goes out, and I constrict that pupil. It's bilateral down here, so if I shine a light in this eye, actually both pupils will constrict. So if I shine a light in this eye, it's the direct light reflex. If I look at this eye, shine a light, this eye constricts, it's the consensual light reflex. It should be bilateral. However, get this, if I cut the optic nerve here, right there, on this side, and I shine a light in this eye, nothing's going to happen, right? Because the optic nerve has been cut. But if I shine a light in this eye, this pupil will still constrict. Even though I'm completely blind in that eye, the pupil will still work. That's kind of cool. There's a condition called an Argyll-Robertson pupil. This is something that develops with syphilis. And what happens here is that when you do the reflexes of the eye, you're going to do direct and consensual light reflex. You're going to do accommodation, so my ability to see that clock is perfect. And then convergence, as I move in with my finger, follow my finger in. I can see my finger, follow it in. My eyes have to converge, right? So to converge, that's going to be medial rectus, which is cranial nerve 3. But also as I move in, your pupil and your lens change shape. That's parasympathetic. So convergence, or excuse me, that's accommodation. I'm able to accommodate to the change in length here. An Argyll-Robertson pupil, the acronym or the thing how to remember it is called a prostitute's pupil, because a prostitute will accommodate but not react. It won't constrict. I didn't make it up. That's how you always remember Argyll-Robertson. Okay. Substantia nigra is here. I showed it to you. This is Parkinson's, obviously. It has quite a big distribution to the caudate nucleus of the basal ganglia. The caudate nucleus, the loop I drew, that's called the caudate nucleus of the basal ganglia. We'll cover that tomorrow. Hearing, the other part of the vestibular cochlear nerve, the reason I'm bringing this up now instead of back down in the pontomedullary junction is because a big significant part of the relay of hearing occurs in the mesencephalon through the inferior colliculi. And this is the thing you need, this is the only thing I'm going to say about hearing, is that if you look at this diagram, hearing comes in here, and so it goes up ipsilateral and contralateral. There's mixing at the colliculus level, again, so that by the time you get up to the thalamus and to the cortex, hearing is enormously bilateral. You never lose hearing with a stroke. You can lose hearing with a nerve problem or an ossical problem, but once it gets in the brainstem, it distributes so widely to both sides, you never lose hearing with a brainstem or cerebral stroke. Yes, Brett?
You would think that'd make it difficult to tell where the sound's coming from.
Or or it's so important that you want a duplicated system that you can see what you mean, that you would want it site-specific. I guess it's the other way around. It's so massive in here in the temporal lobes, you have a lot of cortex dedicated to precise localization. Actually, the hearing pathway is what's called tonotopic. Once you get into the brainstem up here, high tones and low tones are found in specific regions. So that by the time you get to the cortex there, high tones are found medially, low tones laterally in the temporal cortex. Vision, in terms of production of the visual pathway, you've got the retina here. The ganglion cells of the retina go to form the optic nerve. The optic nerve comes here. You remember the chiasm, remember the optic tracts, which ones cross, which ones don't. Their target is the lateral geniculate nucleus. This is what we'll talk about tomorrow. This is in the thalamus. So all sensation goes through the thalamus. There it is hitting the thalamus. There's also visual information into the superior colliculus that will go to form one of those tracts that I had on the slide yesterday, the tectospinal tract. The tectospinal tract originates from the superior colliculus and is responsible for the movement of your head with visual stimuli, reflexively. So the tectospinal is really, it doesn't go all the way down to the spinal cord, it just stays up here in your neck muscles, neck and shoulder muscles. And that's all we're going to talk about regarding the brainstem. Okay? Any questions?
For the Argyll-Robertson pupil, is it going to be unilateral or bilateral? Like, does the syphilis usually affect just...
It's both, yeah, it affects both sides.
Okay.
Yeah. So when you do accommodation, you have to constrict and dilate both sides as you move in and out. Okay? Enjoy your lunch.